Hey guys, welcome to Pre-Calc lesson 6.8. It's going to be a mixed review of all of our conic sections. So before we get to the actual notes, I just want to point out again, in Schoology, you've got two very good resources. One of them is called the Conic Section Organizer, which is basically a PDF file that outlines all four conic sections, starting with a circle, gives you all the relevant formulas, a visual, moves on to an ellipse, general form, standard form, x pole, y pole, a, b, eccentricity, lateral recta, all of that relevant information about an ellipse, parabolas, an x equals y squared versus a y equals x squared type parabola, directrix, focus. Again, all of that is there in this particular PDF file. I know it looks overwhelming, but remember, the more visual you make these, the less memorization you have to do. Also in Schoology is our Keep It Straight chart. This is a single PDF, kind of has everything in front of you on one sheet. Gives you the standard form, starting points, whether it's a center or vertex for a parabola. Focal pull, those two equations are very important. The focal pull for an ellipse versus the focal pull for a hyperbola. It gives you the formula for A and P in a parabola, and also how to find the foci. And again, I don't really memorize these formulas. I'm more visual when I do these, but I don't care how you come up with it. You just need to be able to find those coordinates, and then the eccentricity for all of those as well. In addition to that, you need to be able to identify the type of conic section from the general form equation. So what you might want to do here is pause the videos. I'm going to go through very quickly and see if you can identify all of these equations as to what type of conic section they are. So I'm going to go through quickly and identify these for you. Like I said, you might want to pause the video, come up with the type of conic section, and then resume. All right, equation 1, I see an x squared minus 4y squared. So since it's subtraction there, that's going to be a hyperbola. In the next one, I see a and b are equal, and it's addition, so that is going to be a circle. In the next one, 3, I only see one of the terms squared, so that is going to be a parabola. All right, in question 4, I see it has an x squared plus a y squared, but a and b are different, so that is an ellipse. Question 5 is actually very similar to number 1. 3x squared minus 2y squared. As soon as you see those signs are different, that means it's hyperbola. Question 6, x is squared but no y squared, so that is a parabola. Question 7, we need to be a little bit careful here. I see a y squared minus an x squared, but notice the y squared is actually negative, so these have the same sign. Basically what I do to start this process is I'll divide everything through by negative, but because those are the same signs but a and b are different, that's actually an ellipse. Question 8 is a circle. It's 7y squared plus 7x squared. A and b are equal. Question 9, 5y squared minus 5x squared. So even though those two numbers are equal, one's positive, one's negative, so that is a hyperbola. And in question 10, the signs are different. Negative 3x squared plus 5y squared, different signs, also hyperbola. Okay, next, in standard form, all right, there's only, I guess we have quite a few, 9 of these. Which type of conic section is it? Number 1, that's obviously going to be a circle. It's our center radius form. Question number 2, that is an ellipse. How do you know that? You're adding, and those two are different, so that's an ellipse. Question 3 is a parabola because there's only one square term, and this is an x equals a positive y squared. So it's a parabola, and it would look like this, sideways parabola. Question 4 is actually a circle because the x pole and the y pole are the same. They are both square root 8. That would be the radius of that circle. 5, because of this, that's a hyperbola. 6, there's only one square term right there. x equals negative y squared. So you just have to identify as a parabola, but it'll be a sideways parabola tipped to the left. Question 7 is an ellipse. 8 is another parabola. It's y equals negative x squared, so that parabola would look like that. And 9 is going to be a hyperbola. Okay, conic sections, just a quick review of why they're called conic sections. They are cross sections of cones in a circle. The plane of intersection is parallel to the base. Remember here, eccentricity is 0. In an ellipse, the eccentricity is between 0 and 1. That's that cross section starts sloping upwards. When that cross section becomes parallel to the edge of the cone, that forms a parabola where eccentricity equals 1. And then for a hyperbola, eccentricity is greater than 1. Just another visual of the cross sections. It's good to have a visual of where they come from, but you're not going to have to sketch them or anything like that. Okay, let's get into some examples here. Day 8, conic section, mixed review. Sketch the following conic section. Be sure to list all key points and relevant information. So again, it doesn't tell you what type of conic section it is. It just says all relevant information. So you just need to know what the expectation is. It just gives you an example here. So center, vertices, x-pole, y-pole, foci, asymptote if it's a hyperbola. This obviously is going to be a hyperbola. How do we know that? Because we have a different, signs are different. So first thing I'm going to do is identify the center. X coordinates 2, y coordinates -1. X pole always comes from the x fraction, so it's a square root of 9 or 3. The y pole always comes from the y fraction, square root of 16, that is 4. The next thing I like to do, I usually do this first actually, is to sketch it. Is it a left-right or is it an up-down? Well, since x squared is positive, this is going to be a left-right hyperbola. So using this thumbnail as our visual and this information, I can sketch the hyperbola. So let's get started on doing that. The center is 2, -1, which is right here. Some of these grid lines are missing. X pole is 3, so 1, 2, 3. 1, 2, 3. The y pole is 4. 1, 2, 3, 4, right there. 1, 2, 3, 4 would be down here, a little bit off the chart. Sorry for that. Okay, sketching your rectangle. Okay, so our asymptote lines are the diagonals of this rectangle. What I'm going to do next is sketch those diagonals. Now remember our thumbnail, it's a left-right hyperbola. That makes this a vertex. I'll make that the second vertex, so we'll call that V2, and then this is V1. So our vertex, our hyperbola goes through the vertex rather, and approaches those asymptotes. Okay, so coordinates of your vertices, V1 and V2. V1 is going to be -1, -1. And V2 is going to be 5, -1. So there's some key information we need to know. We also need to identify the center. Next, it doesn't really matter. We need to get the asymptotes. We need to get the eccentricity. We need to get the foci. I'm going to get the equations of the asymptotes first, just because I don't need to do a whole lot. The equation of that line is going to be y plus 1. Remember, I get it right from the standard form equation, equals plus or minus y pole over x pole. Right? I mean, you can count and find slope that way, but we don't actually need to use the graph to get it. So that's going to be 4 over 3 times x minus 2. For foci, remember your c² equation is a² plus b² for hyperbola. So we get c² equals 16 plus 9. That's going to be 25. Square root of that. C is 5. That's a nice easy number to work with. So that's the distance from the center to the focus. And remember, it's on the same axis as those vertices. Okay, so let's go 5 from the center. 1, 2, 3, 4, 5. It's actually out here. That'd be F2. And 1, 2, 3, 4, 5. F1 would be there. And what are those coordinates? Let's see, F1, it's going to be -3, -1. And F2 is going to be 7, -1. Okay, so I've got center, I've got vertices, asymptote lines, foci. Only thing that's left, eccentricity. All right, eccentricity is C over A. I'll do this in blue, I guess. Our C value we said was 5. A, now here's where we have to be careful, right? I didn't specify A or B in the beginning, but remember, for a hyperbola, A is not necessarily the larger of the two. A is always under the positive variable. So in this case, A equals 3, not 4. So that's going to be 5 over 3. Let's just say that's 1.667 to the nearest thousandth, which makes sense because eccentricity of hyperbola, it's got to be more than 1. Now let's review a little factor by grouping. Example 1, I've got 5x cubed minus 7x squared plus 10x minus 14. Usually the first thing I try and do is group these into 2 sets of binomials, take out a GCF. It doesn't always work, that's the first thing I try. So here I'll take out an x squared. I'm left with 5x minus 7. Now the only way that this is going to work is if over here I end up with a 5x minus 7 as well. So I have to take out a GCF from those that will allow me to get a 5x minus 7. Which just so happens if I take out a 2 and divide both of those by 2, I get a 5x minus 7. So this is actually pretty straightforward. The GCF of these two terms is now the 5x minus 7. So that comes out front. What's left in the parentheses is what you get when you divide 5x minus 7 from both of those terms, which would just be your x squared plus 2. Now, if you could factor x squared plus 2, you'd have to go ahead and do that, but obviously in this case, that can't be simplified anymore. Example 2 is extremely difficult. So here's why. We can't really break this up or group this into 2 factors of 2 because there's no GCF there, and even though there's a GCF here, it's not going to get me anything that's going to be similar to that. So I have to use a trinomial and a single term. But here's the problem. Look at this trinomial. I can't factor this, but I can factor that, not the way it's written now. So what I need to do is really rearrange this stuff. So I'm going to have an x squared minus y squared plus 10y minus 25. So all I did first was rearrange the order. I'm actually going to group these 3. I can factor this, but I can't factor this if it has a negative. So what I'm going to do next is I'm going to take out a negative, which means I need to use parentheses. If I take a negative out of here, I have a positive y squared minus 10y plus 25. So let's see what that looks like. Positive y squared minus 10y plus 25. So now this I can factor nicely. That's going to be y minus 5 times y minus 5, which is y minus 5 squared. Okay, so that gives me x squared minus y minus 5 squared. Now this is really the difference of 2 perfect squares. A minus b, a plus b. A is going to be x, and b is going to be y minus 5. Well, again, we have to be careful here with parentheses. So here's my difference of 2 perfect squares. One's plus, one's minus. This will be x and x. This will be y minus 5 and y minus 5. So I'd be okay if you left it like this. That's fine. But if you want to clean this up a little bit, you could distribute this negative here. All right, so the first factor would stay x plus y minus 5 but the second one would be x minus y plus 5. So either or of those are okay. Like I said, though, this one is particularly challenging because of that negative in the beginning. Okay, next, put into standard form in Sketch. Be sure to identify all relevant information. First thing, let's identify this conic section. Well, that's pretty easy. A equals B, they're both squared, so this is going to be a circle. Put this into standard form. Let's group our x's. X squared minus 2x. Group our y's plus y squared. There is no y term, so this is just going to equal 19. Don't forget I'm adding 19 to both sides. That means I just need to complete the square root of the x's. Half of 2 is 1, 1 squared is 1, add 1 there, add 1 there. So now I get x minus 1 squared plus y squared equals 20. That's my standard form equation of a circle, or what we call center radius form. The center is going to be 1, 0, and my radius is going to be square root 20, which is approximately, I don't know, let's call it 4.5. I need to sketch it. Now, before I sketch it, I want to point out something here. Some of you might be conditioned when you get to this point. Let's say you didn't realize it was a circle. You're like, well, everything always has to equal 1. Everything always has to equal 1, so I always divide by 20. Well, that's totally fine. I get something that looks like this. X minus 1 squared over 20 plus y squared over 20 equals 1. And you might be going under the assumption that maybe this is an ellipse. But check it out. You still go through the same process. My center is still going to be 1, 0, but now you might do something like this. Oh, well, the x pole is the square root of 20, and the y pole is the square root of 20. Both of those are the same. So whether you recognize this as a circle or treat it as an ellipse, but then understand, well, the x pole and the y pole are the same, oh yeah, that just means it's a circle. It doesn't matter. You're going to end up with the same sketch, and that's kind of cool. And also, that would be acceptable if you leave that as your standard form equation of a circle. That's equivalent to this one right here. All right, super quick sketch, then we'll move on. So my center is 1, 0. There's my center. My radius is square root 20. Now, obviously, I can't do this precisely, but it's between 4 and 5. So let's go 1, 2, 3, 4, 5, and just put some point in between there. Let's go up. Let's see, sketch just a little bit more. 1, 2, 3, 4, 5. And somewhere in between those, go left, 1, 2, 3, 4, 5, somewhere in between those, and down, 1, 2, 3, 4, 5. So I'm just looking at mine, it's not very good. Yeah, I don't know how that happened. 1, 2, 3, yeah. And then maybe just label this as square root 20. The directions are the same for example 4. I'm going to give you a general form equation, identify the conic section, put it in standard form, identify all relevant information, and sketch. So this right here is going to be an ellipse because A does not equal B. Let's group our x's together, 6x squared plus 24x, then group our y's, plus 3y squared minus 18y. Subtract 39 from both sides. Next thing I need to do is take out a GCF in both groups. So I'll take out a 6 here for the x's. That gives me x squared plus 4x. Take out a 3 for the y's. That leaves me with y squared minus 6y. And that equals negative 39. And now we're going to complete the square. Half of 4 is 2. 2 squared is 4, but I'm not really adding 4. I'm adding 24, remember. So add that to the other side. With the y's, half of 6 is 3. 3 squared is 9, but I'm not really adding 9. I'm adding 27, 3 times 9, so add that to the other side. That's the hard part. We're done with the hard part. The rest is pretty straightforward. I factor, so I have 6 times x plus 2 squared plus 3 times y minus 3 squared, right? Just a reminder, that determines what the sign is in both sets of parentheses. And then here I've got negative 39 plus 24 plus 27. What does that give me? 12. And then I divide both sides by 12. Again, when you get to this step here, if this number does not cancel with that, chances are you did something wrong. All right, my guess is probably forgetting to multiply by the number out in front, but we won't give you an equation that's so messy that the numerator does not cancel with the denominator. So here I get x plus 2 squared over 2 plus y minus 3 squared over 4 equals 1. So there's my standard form equation. I'm running out of room here. All right, so I'll write a little bit smaller. My center is going to be negative 2, 3. This is going to be a little bit messy. X pole is the square root of 2, which is approximately 1.4. My y pole is 2. All right, so I'll make a sketch over here. Center is negative 2, 1, 2, 3, 1, 2, 3. There's your center. X pole is between 1 and 2. So right about there. 1, 2, right about there. Y pole is 2, so go up 2 and down 2. All right. So kind of a small ellipse. Remember, it's more watermelon than football, rounded on the edges. On the endpoints, I should say. Okay, let's identify some key points. This will be V1, my vertex, and it'll be V2, my second vertex. Those coordinates are relatively easy to get. V1 is going to be negative 2, and then I take the y pole and add it to the y coordinate. So that'd be 5, or you could just use your sketch. V2 is going to be negative 2, 1. Okay, so I've got my standard form. I already identified the center. I've got my vertices. What's left? Foci. For an ellipse, c squared equals a squared minus b squared. So what I get here is going to be 4 minus 2 equals 2. So c equals square root 2, which we said is approximately 1.4. So I'm going to go up about 1.5. There's f1, down 1.5. There's f2. Now this is where it's a little bit harder to come up with the coordinates. Remember what we're doing. We're taking this value of c, which is the square root of 2. We're going to be adding it to the y value of the center. That's how I get f1. To get f2, I subtract it from the y value of the center. So I really don't even need to look at my graph once I realize I'm going up and down. So f1 will be negative 2, comma 3 plus square root 2. f2 will be negative 2, comma 3 minus square root 2. And eccentricity, lastly, we'll get that. Eccentricity, remember, is c over a. C is square root 2. A in an ellipse is the larger of the two poles. So in this case, a is going to be 2. And most likely it'll say like 10 nearest thousandth. It's a little bit more meaningful that way, so I get 0.707. Okay, there's all the relevant information with this ellipse. Example 5, write the general form equation of the conic section with a minor axis equals to 4, center at negative 5, 6, tangent to the x-axis. I don't really have an idea of what's going on here, so let's make a quick sketch. I know the center is negative 5, 6. Let's start there. Negative 5, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So there's your center. The minor axis is 4, and it's tangent to the x-axis. Well, if this is tangent to the x-axis, that means it's got to intersect right here, right? It's got to be the vertical. So that's a point on this curve. Well, this distance here is 6. That'd be your y pole. That means the minor axis is 4. So there's another point there. I'm looking at an ellipse. And really, right here is all the information I need to come up with the equation. I know the coordinates of the center, I know the x pole, and I know the y pole. Okay, so let's write that equation. X minus the x coordinates, that'd be x plus 5 squared over x pole squared, which is 16, plus y minus the y coordinate of the center squared over the y pole squared, which is 36, equals 1. Great, I'm done. Except we're not. General form. Ugh. So general form, guess what? We've got to do some algebra. We've got to FOIL those out, and we got to get rid of these denominators here. So how do we do that? Well, one thing we can do is we can multiply every term by 16 times 36, whatever that is. I have no idea what that is. Or we could be a little bit more efficient and find the lowest common denominator. What number do both 16 and 36 go into? It's 144. So that is what I'm going to multiply every fraction by. So multiply by 144, multiply by 144, and on this side I'll multiply by 144. Okay, well, 16 goes into 144 9 times. 36 goes into 144 4 times. Now what I'm going to do is multiply this stuff out. Well, I'm not going to take a lot of time to write all this, but you need to understand that x plus 5 squared is x plus 5 times x plus 5. And at this point, you really should be able to do this stuff in your head. So if I multiply those out, this here is going to give me x squared plus 10x plus 25. So I'll start by writing that. 9 times x squared plus 10x plus 25 plus 4 times y squared minus 12y plus 36 equals 144. So now what I need to do is now I need to distribute 9 with my x's, that trinomial, and 4 with this trinomial. It's all algebra. It's a little bit of work, but no big deal. So this will give me 9x squared plus 90x plus 225 plus 4y squared minus 48y plus 144 equals 144. So now to get this into general form, remember what general form looks like. Ax squared plus by squared plus cx plus dy plus e equals 0. So I need to subtract 144 from both sides. Well, that's kind of convenient. Those will just cancel. Next, let's rearrange our terms. So I have 9x squared. Next, I want the y squared term plus 4y squared. Next, my x term plus 90x. Now your y term minus 48y. And then just whatever we have left, which is that 225, equals 0. So that is your general form equation. It's a great exercise in algebra right there. Okay, moving on. Example 6. Get the following in standard form. Find the vertex, focus, directrix, and sketch. Well, it's already in standard form. Awesome. Next thing I want to know is if this is x equals y squared, what type of parabola is that? X equals y squared opens to the right. Okay, so I know I'm going to be sketching a parabola that looks like this. Next, let's get the vertex. All right, I like the form that this is in. Remember, the vertex is going to be the opposite of what's with the x, so that's a 1. The opposite of what's with the y, negative 1. And I know it opens to the right. Okay, so my vertex is 1, negative 1. I know it opens to the right. I know my value of a is 1/2. So normally what I do to get a parabola is I go out 1, up 1, right? But this is sideways, obviously. Since a is 1/2, I'm going to go over 1, up 1/2 to get those points. Then instead of going over 2, up 4, I'm going to go over 2, up 2. And really that's all I expect you guys to get. You could go over 3, up 4.5, but that's fine. This is a pretty good sketch of this parabola. Okay, so the vertex coordinates, I got those here. Good. Find the focus and directrix and sketch. So I've done the sketch. Now, to get the focus and the directrix, we have to remember this. I need the distance from the vertex to the focus or the vertex to the directrix. That distance is p. There's one formula you have to remember. P equals 1 over 4a. Now, if I have to work the other way from the picture to the equation, a equals 1 over 4p. We'll need to know both of those, but it's the same formula. So to get that distance, it's going to be 1 over 4 times 1/2, which is 1/2. So the distance from the vertex to the focus is 1/2. You have to visualize the focus is always inside the parabola. So there's your focus. That distance is 1/2. The directrix will be a vertical line that is 1/2 units away from the vertex. Okay, so the coordinates of your focus are going to be 1.5, or 3/2, comma, -1. Okay, got that. And your directrix is going to be a vertical line, so it's x equals, and what's that x value? 1/2. Example 7 is not quite as easy as the one up above because it is in general form. So what I need to do is I need to put this into standard form. I'm noticing that the x is squared, so we'll start by grouping those x's. X squared minus 6x, and I'll move the other terms to the other side, so positive 4y minus 5. Complete the square on the x. I'm going to take half of 6 and square it, so I'm going to add 9, and I'll add 9 to this side. So now this gives me x minus 3 squared equals 4y plus 4. Now I want the y by itself, so I need to divide everything by 4. Remember, when you divide by 4, it's the same as multiplying by 1/4. Now I'm also going to take this stuff and move it to the other side, and take this and move it over here. So I'm just going to flip the equation, if you will. That's going to give me y plus 1 equals 1/4 times x minus 3 squared. That is the standard form equation. Some of you might prefer moving this over here, and you could just fine, put -1 on the end. I kind of like keeping it like this because it's easier and quicker for me to find the vertex. So the vertex is going to be the opposite of what's with the x, that's positive 3, opposite of what's with the y, -1. Got it. Also, I recognize this as a y equals positive x squared, which is your typical happy parabola. It'll open up. So let's get that vertex 3, -1 right there. And notice your value of a, your vertical stretch is 1/4. So typically we go out 1, up 1, but we're only going to go out 1, up 1/4, and then out 2, up 1 instead of up 4. So these points here will be on this parabola. All right, so it'll be up 1/4 there, up 1/4 there, up 1 there, up 1 there. It'll be kind of a wide parabola. So there's a good enough sketch. Now, I need to get the focus, I need to get the directrix. All right, well, how do I do that? I have to use that formula, P equals 1/4a. P is the distance from the vertex to the focus. That's going to be 1/4 times 1/4. Well, 4 times 1/4 is 1, so that distance is just 1. That's kind of nice then. The focus is going to be inside the parabola, 1 unit away from the vertex. So there's your focus. The directrix line will be 1 unit away on the other side, and this will be a horizontal line. So the coordinates of your focus are 3, 0, and the equation of your directrix line is going to be y equals, because it's a horizontal line, and it's just y equals -2. All right, hang in there, guys. Only 2 more examples. We're almost done. The 2 application problems. And this question says the filters of an elliptical pool must be placed on the foci. If the pool is 42 feet long and 26 feet wide, describe the precise location of the filters. All right, so we have an ellipse. All I know is that it's 42 feet long, so the total length here is 42, 26 feet wide. Now, I'm not talking about an equation because I'm not on a coordinate plane. I just need to describe where to put these filters. They're on the foci. Well, the foci will reside approximately here and here. Well, what part of this ellipse do I need to find? Well, if I'm talking about foci, I need to use this equation. Now remember, this is an ellipse, so the c² equation is a² minus b². C is going to be the distance from the center to this focus. What else do I know about this ellipse? Well, I do know A and B. You just have to remember to take half. So this distance here is half of 26, or 13. This distance here is half of 42, or 21. So my c² equation is going to be c² equals 21 squared minus 13 squared, which we'll just throw into the calculator, and that gives me 272. So c equals the square root of 272. to the nearest hundredth, I'll say 16.49. Now, all the math here is great, but I haven't described the precise location of the filters. So now I need to answer that question. Place the filters 16, we'll call it 0.5 feet from the center of the pool on the major axis. Now, if I don't mention on the major axis, I have a whole slew of locations I can put the foci. If I just say 16.5 feet from the center, that's anywhere on this circle, because there's my center, and that's 16.5. So I have to mention that's on the major axis, 16.5 feet from the center. Okay, so don't forget that part. Example 9, the reflector of a motorcycle headlight is parabolic in shape if the bulb must be 1 inch from the back of the headlight and the headlight must be 3.5 inches deep in order to fit the mounting bracket. How wide must the engineers make the headlight to maximize its reflective properties? All right, so a quick sketch here. Got this headlight. The back of it is parabolic in shape. And just a reminder, that's to maximize the reflective properties of that parabola. If we place the bulb at the focus, all those light beams come out parallel. Okay, so that bulb is 1 inch. So the focus there is 1 inch from the back of the bulb. It also tells me that the headlight is 3.5 inches deep. And I want to know how wide to make this headlight. So what I want to do now is I want to take that and put it on a coordinate plane. I want the vertex to be 0, 0. Why? Because that's the easiest. I want to open up. So here's my cross section of the headlight. I know the focus right here is 1 unit away. I also recognize this as 3.5 inches deep. Well, that's this part here. That's 3.5 inches. Okay, so that is 3.5 inches. That means this point here, this coordinate xy, has a y value of 3.5. I'm looking for x because I want to find how wide this is. In order to find how wide that is, I need to find this x coordinate and then just double it. And that's going to be the width of the headlight. All right, well, what do I know? I know P equals 1. The distance from the vertex to the focus is 1. So P equals 1 over 4A, or A equals 1 over 4P. Okay, so let's use that one. A equals 1 over 4 times 1, or 1/4. So A is 1/4. The other thing I know, since I'm creating this simple parabola equation, that's going to be y equals x squared. Since the vertex is 0, 0, it's going to be y equals ax squared. That's it. All right, so if I take that, y equals ax squared. A, I know, is 1/4, right? X, I don't know. I'm looking for x, but the y coordinate I know is 3.5. So I'm just going to plug that stuff in. I get 3.5 equals 1/4 times x squared. Well, now we just solve this equation. Let's multiply both sides by 4. 3.5 times 4 is 14. That equals x squared. Square root that. Square root of 14 is approximately 3.74. Now remember, what does that represent? That represents the x coordinate, so just that. If you want the width of the headlight, you're going to have to take 2 times that. And that's going to be approximately 7.5 inches wide. All right, great. That finally concludes day 8. This has been a marathon. But hopefully it's a solid review of every single thing that we've done in this Unit 6. And now you guys should be in pretty good shape to complete the work session, the review, and be prepared for the exam. But as usual, if you have any questions, don't hesitate to reach out. Thanks for watching.